Alright, so for the final subsection itself, this is the part where a lot of students will actually find it very, very difficult, is because this part is very heavy on the explanation, very heavy on standard answers itself. So number one, why do gas exert pressure? So for example, even your atmospheric pressure itself, or even if you're sitting inside a room, why is there atmospheric pressure? Why is there air pressure acting on you? Because number one, all your gas particles are in constant random motion itself. And what happens when they collide with the walls, they will actually exert force per unit area itself. So you see there's three things. Number one, what happened? How do they collide? And what happened when they collide? So because they actually exert a force per unit area itself, there will actually be a pressure. Now, this word average, do we need the word average? Yes, because it's linked to the word random, because we don't know how many particles are colliding against the wall at this time. Like time 1, maybe you have a certain amount, time 2 is a different amount that's colliding. So whenever you are dealing with anything that is random itself, the only thing we can do is estimate. We can only estimate how much and how often you actually collide with the walls itself. Okay? So just to reiterate, whenever you have a difference in pressure, you always have high pressure versus low pressure itself. Now, why do I mention this itself? For example, if you have a balloon, inside is the same pressure as the one outside, right? So pressure in equals to pressure out. What happens if you were to blow air in? When you blow air in itself, pressure inside is greater than pressure outside. So what happens is that the balloon will inflate till pressure in is now equals to pressure out again. Okay, so just keep this in mind itself. Now, next one is talking about ideal gas law. Now, not all schools cover this part itself, but they actually break it down into its individual components. But this is usually used for mostly for the IP schools itself. But this is just something that is good for you to know. Pressure is nRT over V. So basically, if you just look at the relationship, only volume is inversely proportional. So if you were to go down the list, basically as temperature increases, pressure also increases. This fella here is thermal expansion. So nothing to do with your gas itself. You can just ignore this one in the middle. So this one is the special one. As volume increases, your pressure actually decreases. So this is the special one over here. And for the one below is that as number of particles increase, the pressure also increase. So this one goes back to the balloon example, because if your number of particles increase, gas pressure increase. If the question is asking you, why does my balloon inflate when I blow air in? You don't have to go to the trouble of describing all these steps. Okay, you can just phrase it using this one, because when you blow air in, number of particles increase, gas pressure increase. The pressure inside the balloon is now greater than the pressure outside the balloon, so the balloon will continue to inflate until the pressure inside is now equals to the pressure outside. Because when you inflate the balloon, don't forget, your volume increase, and when your volume increase, now your pressure inside decreases. So once it decreases till it's the same as the outside pressure, then it stops inflating. So these fellas over here are asking you why. Okay, maybe not the middle one. This one and this one, these two are asking you why pressure change. Why is there a change in pressure? Because number one, if you notice, if I increase the temperature, the average KE of the gas particles increase. So what happens? You move at higher velocity, you collide more frequently. If you collide more frequently, greater average force per unit area. Okay, so next one, if I increase volume, space increase, I will collide less frequently. Okay, so if I collide less frequently, smaller average force per unit area. Next one, if number of particles increase, I will collide more frequently, I will have a larger average force per unit area. So you can see factor that change, what's the effect, what's the outcome. So you can see it's always factor, whether you collide more or less frequently, then what's the result afterwards. Okay, so for the one in the middle itself, this one is mostly due to your mass, volume, and density. So density is mass over volume. So mass is the same, volume increase, density decrease. This one have to do more with the later part itself, but this is thermal expansion in reverse, thermal contraction itself. So you just need to take note of this. This explanation is actually nothing to do with the gas pressure, but it is still under kinetic particle model, because you're talking in terms, you're describing or explaining in terms of particles why volume increase when temperature increases itself. Okay, so but this one, the placement is a bit off. It should be at the bottom on its separate self. The top one and the bottom two are talking directly about gas pressure. The second one doesn't talk about gas pressure. So just be careful. You might want to do your own self notes based off this. Okay. Now, if you look over here, there's two questions. So question number one, this is silk. Change in pressure when piston is pushed to the left. When your piston is moved inwards, what happens? The volume decreases, right? So when the piston is pushed to the left, the volume of air decreases. The spacing between air particles decreases, and they collide more frequently with the walls of the container of the pump. The air particles will exert a larger average, must have the average, force per unit area, and thus a larger pressure. And thus, you can also say that thus the air pressure increases. Okay, so yes, I need the word average. Okay, so you can see over here, first things first, I talk about volume of air decreases, spacing decrease, I collide more frequently, I have a larger average force per unit area. Oops, there's a typo there. Force per unit. The words are not cooperating. Okay, give me a second. Larger force per unit area. Okay, let me just highlight it. Okay, the highlighter was interfering with my text. Okay, so basically this is how it will work, and you just need to be careful of this. So you can see what happens over here. Ultimately, you just talk about the factor that change, volume decrease. So what does that mean? I will have more smaller spacing, I will collide more frequently, and therefore larger average force per unit area. Now, next one. Why does a balloon inflate when air is being blown into the balloon? So when air is blown into the balloon, the number of air particles increases. The air particles, because this is 3 marks, I want to be more precise, more concise, just explain everything. The air particles will collide more frequently with the walls of the balloon, and thus, okay, I don't know, collide more frequently, the air particles will exert a larger average force per unit area, and this increases the air pressure within the balloon. Since the air pressure within the balloon is now greater than the atmospheric pressure outside. The balloon will inflate until the pressure inside is equal to the pressure outside the balloon. Okay, so basically just this part. Now, if this was a 2-mark question, I would just say when air is blown into a balloon, number of air particles increase, the pressure inside the balloon will also increase. Since there is a difference in pressure, the balloon will keep inflating until the pressure inside is equal to pressure outside. So, but this one, because they tell us to use in terms of molecules, they want us to be more precise. Why pressure inside is bigger than pressure outside itself. Therefore, I actually need to elaborate further and describe how the pressure inside increases, and therefore it will actually affect why the balloon will inflate because of the difference in pressure. So why is there a difference in pressure? Because my pressure inside increase. Why does pressure inside increase? Because my number of particles increase. Therefore, that is why the balloon will inflate.